Hello and welcome back to another tutorial of SystemVerilog in 5 minutes. Today we'll start with the hardware concept, signals modeling. In Verilog, two syntaxes were created to represent signals. One is called wired and another one is called a reg. This is how you create signals by using wire or reg. Wire, as the name implies, is used for connectivity. A reg stands for register, although it is really not a register. You can create multiple wires and multiple reg. You can also create multiple bits version by using square bracket notation. The differentiation between wire and reg is that there is a rule on how to use them. Wire should only be used with continuous assignment, whereas reg should only be used with sequential statement, aka the always block, or with procedural statements like the initial block. While I said it is a general rule, this rule is not strictly followed by many simulators nowadays. Now let's try to understand this code from a synthesis perspective. The continuous assignment here will connect W0 to a high supply, whereas this one will create one AND gate and connect W1 to W0 and R0. For the always block, it will create one AND gate plus one register, where R1 is connected to W0 and R0. Initial block is a pure simulation code. It cannot be translated into any logic gates and connection. It is only used in simulation as a test bench, where it can derive stimulus to the design. From a simulation perspective, we need to look into the behavior of the signals. Clock is an input signal. Let us assume this is how it behaves. W0 is hard connected to high from the beginning. R0 is driven to high at the beginning. W1 will follow W0 and R0 at all time. R1 will get the value of W0 and R0 at every positive edge of clock. Before we proceed, I would like to admit that there are many bad things in this code and illustration. For example, we do not know the value of R1 at the beginning because it was not initialized, unlike W0 and R0. Up until the first clock, R1 was unknown. A proper way is to initialize the design signal through the use of reset. The reset code is not used in the original example here because I was trying to avoid the fonts being too small. Another thing is that the always block uses blocking assignments instead of non-blocking. Non-blocking assignments is quite huge a topic by itself and therefore it is skipped in this tutorial. Anyway, the message I'm trying to bring up is that while I try to create error-free code, there are some areas that I oversimplify and some concepts that I skip to facilitate understanding. Now let's move on. If you are new to this and if you follow the rules strictly, you may find the wire and reg are somewhat confusing. Which one is to be used and when to use it? A new syntax is added to represent signals, supposedly to simplify coding. It is called logic. You can create signals using logic just like how you can do it with the reg and wire. The advantage of logic is that it can be used with all initial block, always block, and continuous assignment. From now on, just the one syntax for all usages, logic replacing reg and wire. Well, almost. Sometimes wire can be connected to multiple drivers. As an example, imagine a laptop having a USB mouse and a mouse pad. You can control the cursor using either of them, but if you use both of them at the same time, the cursor behavior is unknown. This is the concept of multiple drivers in hardware, and this is the case where logic cannot handle. You can use logic with continuous assignment, but you cannot derive a logic signal with multiple drivers. Only wire can do that. Let's study more about multiple drivers. In this example here, there are two initial blocks. One is driving L0 to 0, and another one is driving it to 1. This is not a multiple drivers issue. This is a race condition. In analogy, it is the same as a television with two remotes. You can press both remotes at the same time. One of them will go first and the other will go second, overriding the first one. This is the same case for the initial blocks. Generally, there is no way to tell which one will go first. Here's another example with always block. There are two always block. Each tries to derive the same signal to different value, but similar to the initial blocks, this is also a race condition, not a multiple drivers issue. Here's another example. There is a continuous assignment and an always block. This is a multiple drivers issue. The assign statement will derive the logic at all time and thus will conflict with the always block at positive edges of clock. This will cause compilation failure. In summary, logic is a new data type introduced in SystemVerilog. It can be used in initial blocks, always blocks, and continuous assignments. Try to use it wherever possible, unless you have a multiple drivers requirement. In that case, you have to use wire. In the next tutorial, we'll talk about numerical variables.